Good day, ladies and gentlemen, and all colleagues in engineering, graphics and design. Today's session is all about mechanical analytical questions. Now remember, where does it slot in? If you go to paper 1 and paper 2, paper 1 consists of civil analytical, and then of course your solid geometry, your descriptive geometry, and then of course your last part of that will be a civil drawing itself per se. And if you go to paper 2, it will be question 1 will be then including the mechanical analytical question, and then of course you will have all the other drawings like geometrical construction, and then also isometric drawings and mechanical drawings. Now the first part of it is of what I will explain to you consists all of the mechanical parts and the components. Now remember that this information I'm going to give you in grade 10 is also applicable for grade 11 up to 12. So the information will stay there. The information that you need to know will be there. And it's so often that learners go to grade 12 final national senior certificate exam and still make the same mistakes that's basically forming part of grade 10 content. So please make sure paying attention in terms of how and what is requested in all these questions. So therefore, this is what I will explain to you. In terms of the mechanical drawings. Now, of course, we have to go a bit wider. We can't just go onto mechanical parts. We have to start with mechanical drawings per se, and we have to take a look at title blocks. We have to take a look at the placement of views. We have to take a look at sectioning the views, cutting the views in half. That is all forming part of question 1 as well as question 4. Now, of course, I can't simply just start explain everything as a unit. So what I will do is I will break the session up into 2 sessions. The first session will be all the analytical type of questions that you can expect, and then a second session of which follows after this one will be then the more mechanical part, in other words question 4, but the detail that you should know of mechanical analytical should also be applicable for the mechanical drawing. So how to understand the whole concept is basically to join these 2 concepts as a unit and see question 1 as well as question 4 on question paper number 2 as a unit. So if you can jump off to the first slide, you will see it all contains about the frame block and the title blocks itself, the frame of the drawing itself. There are 2 different types of blocks, title blocks that you can get, the civil title block and also a mechanical title block. Now, the difference between the 2 is the civil title block will always pile up from bottom to top. And this is a simple, straightforward type of title block for a civil drawing. Over here you can see this civil drawing title block has been piled up with lots of detail. There's about 13 to 15 different types of detail that you can place inside this title block. The prominent and the most important part of it is the fact that you will always pile it vertical upwards to the top. If you go to this title block that you see over here, it is more horizontal. There's more information going from left to right or right to left, doesn't matter. And then it is with a more advanced or more detailed type of title block. This is basically giving you more information. There's also lots of information involved into a drawing like this. I will show you afterwards on those examples itself. How do you prepare a mechanical or a civil title block? Now, first of all, you get your clean page. Normally with an A3 page, you will go about 15 millimeters from the side or the edge of the paper. If it's an A4, of course, if you go 15 millimeters from the edge of the paper inwards, there's basically a lot of space being used up by the frame block. So therefore, with an A4 page, we will go only 10 millimeters. But if you go to A3, it's normally 15 millimeters or so from the side itself. All right, so you will plot the corners in terms of distance, 15 millimeters from the edge, 15 millimeters from the edge, and then all the same on this corner and that corner over there, and also the corner on that side. So once you've got that, you can simply just join those lines. Of course, if you do it with a T-square and a set square, it's going to be much faster. And then from there on, you can start measure out the dimensions that you will need. Let's say, for instance, in this case, for a mechanical title block that extends to the left and to the right. So measure it. Normally you will work on a 75 millimeters, but it's not compulsory. You can make it shorter, you can make it longer, depends on the heading and all those type of things and so on. Right, so from there on you will type or write, making use of type A lines in this case. So in other words, that will be dark outside lines, continuous outside dark lines in other words. Okay, and then after that you can subdivide some areas of which you have to add some information on. And then with the heading, normally the heading will be a bit bigger, so therefore we will place the heading a prominent area, in other words on top of this piled up lines that you see over here. And then if you do the lettering, just remember that the lettering is normally like Gothic printing. If you go to your computer, the lettering that you will see over there. There we go with that. Arial is also very close to the correct size. There's a few things that you have to understand about lettering. It's always, you will always draw neat or right in between guidelines. Normally the guidelines are forming the fence lines that it doesn't go over. Like for instance in the case of a Y, you're not going to go down the line, or it's all between the guidelines over here. Most of the times, unless stated otherwise by the examiner, it will be caps locks. In other words, using uppercase letters in that regard, so like you see in this case over here. And then of course, if you draw the letter, like I'm saying, it's drawing, it's not actually writing it. It's always the wider you can go, the neater the drawing will look like. Right, so the same with B. If you go horizontal for the top, middle and bottom part before you start curling it back, it looks much neater in the process. Right, so there we go. You can see also the directions on how you draw a C and a G and a whatever the case might be, as wide as possible, and that will help you. You can see over here the Y doesn't extend over the line. It stays in between the fences of the guidelines that was drawn. All right, so there we go with the 7 millimeters. That's where we were with the previous time. And then from there on you will place the heading of the drawing. In this case it's a casting or something like that. And then of course you also have to a great extent have to do the smaller letters or the smaller annotations. And normally that will be in the vicinity of 4 millimeters if it's not to the heading. So therefore it's 7 millimeters or 9 millimeters for the heading. For the other lettering that you will use for the annotations, that will be there in the vicinity of 4 millimeter. And then of course it will things like scale, initials and surname, your grade, the date, the task number, the address of the task, where can you find this task in your textbook afterwards, and so on. Right, so if you go to first and third angle geographic projection, with first angle geographic projection, we will be used that in paper 1. Now, obviously, it helps you to understand that because first angle geographic projection tells you it's a number 1, and that can be seen as an arrow. So if we take an arrow and we shoot it through the target, it will hit something on the other side. In other words, if it's a paper target like this on what we are working on, it will go right through towards the other side. So therefore, the left view, I will look at it from the left-hand side, and then I will place the view on the right hand side as the arrow went right through to the object. All right, so that's the difference. So the top view will be obviously seen from above, but it will go right through the target, and then it will be placed on this side of on the bottom side of it. Okay, that will be for paper 1 for civil analytical, solid geometry, interpenetration, perspective drawings, and also civil drawings. If you take a look at third angle geographic projection, it's the same object of what I've used just now. But now you can see 3 tells you start here, but you go back to your root, and you start on that side and you go back to your root. So if it doesn't ring a bell, then in that case with the number 3 going back on root, I will be looking at it from this side, from the left hand side. But 3 tells me you have to place it on this side. So if I see what it looks like, I will place it on this side. So it's still a left view. And like in the case of first angle, the left view was placed on the right hand side, but in third angle, the left view will be placed on the left hand side. And that's what you see in that regard. All right, so off we go. We go back to the root, and we go back to the root. So we will place the left view on the left hand side over here. Obviously, we'll understand that the top view will be seen from above and will be drawn backwards like 3 tells you. Go back on your root. So therefore, the top view will be placed always above the front view or below the front view, like in first angle. In this case, third angle, it will be placed above, on top of, in other words. the front view, and that's the top view that you will see over there. All right, ladies and gentlemen, that is what I want to say to you about that. Paper 2 is mechanical and analytical questions. It will be loci of cams and mechanisms. It will be isometric drawings, and it will be mechanical work drawings, as you see over there. All right, then the placement of the views. Now, I have to start with my drawing. In other words, this is the view that the examiner is giving me. He's asking me to place this and to draw the front view. If you read through the question, it's asking for a top view and it's asking for a right view. Now, like I said, the top view will always, if this is the anchor, if this is the front view, seen from above in third angle orthographic projection. Sorry, I just want to go back to this part over here. In third angle orthographic projection, it tells you that the top view will be going back to the top, and that is where we will find the top view over there. And then if you go to the what you call it, the left view in this case, it's given as the left view, and the left view has been seen from the left hand side, taken back and placed on the left hand side over here. All right, so that is what you can see within this regard. Okay, so if we go to the right view, the examiner is asking for the right view, so the right view will be placed over here. In other words, if I take the left view will be placed in that position. What if the examiner is asking for a bottom view? So that's not too far-fetched, because in 2020, the examiner asked for grade 12s a bottom view. He pointed out a bottom view. All right, so the bottom view obviously will be seen from the bottom and then placed back to the bottom itself, to where you're looking at it. In other words, it will be placed on the bottom in this case. The top view placed on the top, the right view will be placed on the right hand side, the left view will be placed on the left hand side in the case of third angle orthographic projection. All right. The placement of the views I will explain with mechanical drawing. If you take a look at scales, now what scales tells you, it's basically made smaller or made bigger in the process, or it stayed the same. All right, so sometimes you have to enlarge, sometimes you have to make something smaller which is too big, and this is known as scaling. Now the scaling should appear to a specific ratio. In other words, 1:1 tells me it's the same size. If it goes 2:1, it means it's 2 times larger. It's 5:1, obviously it's going to be 5 times larger than what the real dimension is. And then if it's 1:2, it tells you it's 2 times smaller. 1:5, 5 times smaller. If you go to house plans, floor plans and those type of things, it can be up to 1:50, 50 times smaller to fit it on an A3 page, or to fit it on an A4 page, even bigger, to 1:75 maybe, perhaps, or so. So over here you can see the different scales. 1:1, this is twice the size, this is twice the size smaller. And then of course 1:2 means that the size has been divided by 2, or it's multiplied by 2. If it's 1:5, the size will be enlarged by 5 times bigger or 5 times smaller if the case is 5:1. Okay, and then very important, this is the portion that you have to understand. And that is, doesn't matter if you have drawn the scale larger, the object, if you've drawn it larger, or whether if you've drawn the object smaller, it doesn't matter. The truth is that the dimension will always be 40 millimeters, 40 millimeters, 40 millimeters, if the distance is measured 40 millimeters. In other words, you don't divide the dimension, you keep the dimension real dimension. All right. I used to say that because of the machine maker's hands is dirty, you can't work with calculators and clean pages and all those type of things, so therefore you haven't got the time in dividing or multiplying or whatever the case might be, so therefore you give him the information as it is in real life. So it doesn't matter whether if it's enlarged or it's made smaller, you will keep the dimension the same. All right, so that's according to scales. The ratio is normally 1 to 2 to 5 to 10 or 20, 50 and 100. But that's not a compulsory. That's not. It can change. In other words, we can work on a scale of 1 to 45. We can work on a scale to 1 to 75, or whatever the case might be. It's recommended in using those, but it's not compulsory. All right. So what you see in hidden detail is, of course, the areas that will be hide behind an area. So if I look at this view or this isometric drawing that I've been drawn over here, there's a hole inside there of which I can't see. So if I look at it from this side, I need to show, listen here, there is some components or there's some features going on inside this part over here, and that is where the hidden detail is going on, telling you there are some detail inside of which you can't see but needs to be mentioned in the process. All right, few tricks about hidden detail lines is that you always try to end your hidden detail line towards a solid line. It's always ending up to that solid line, and then also if it intersects with the solid line, it will be balanced either to either side, the same gap or the same line, in other words, if it needs to go over a solid line in that case. All right, and then also if it joins up into a corner like that one, you normally will see that the corner will end up more perfectly onto that corner itself. And then also if a T, then it's the same apply towards that part. Then this part over here, if it turns into a Y, you have to start with the lines, end with the lines, and start with the new line from that specific corner itself. All right, so that helps with accuracy. This part over here points out that if a line is solid and it turns over to go from there to a dotted line or a dash line, hidden detail line in other words, you will always keep a distance open, and then from there on you will start with your hidden detail line. Otherwise it looks as if this line has slipped too far and it looks untidy, so therefore it stops at where it's supposed to stop, and then the gap, and then after that you start with your hidden detail line from there further onwards. Then of course this part over here is also pointed out to you that if a dotted line or a dash line turns into a straight line, doesn't matter, you stand wide-legged onto the center line or where it starts to turn into a straight line. All right, so in that case, but now if it goes from an arc, solid arc towards a dash arc, it will have the gap like I've explained to you a few slides earlier. All right, then more detail about hidden detail. Of course, the details should be accurate. If the drill has been sharpened on 30 degrees, it should be 30 degrees on the bottom. If you use a die for cutting thread and it's edged off at 60 degrees, for instance, then of course your hidden detail line should also be 60. Look at the detail where the lines join and where the lines end up with the solid line and those type of things. With bolts, it will be 45 on the bottoms. And then from there on, where the die ended up with the shaft, that's going to be 60, like in the case where it started with the hole. That will be 60 degrees, so therefore that should be 60 degrees at all times. That's 45 on the edges on there, as well as on the top over there, and of course it will be 60 degrees on the clean part of the shaft. Then if you put a washer on, normally you won't hatch or cut through the washer itself, and you won't cut through the nut also as well. Right, so this is a spline. Sometimes it appears that the dimension, the hidden detail lines can be very close to each other, in some sort of way confusingly close to each other. All right, so this is the case where you have to show all the lines. Now luckily it's symmetric, so therefore the front part and the back part looks exactly the same, and therefore we don't show the back part also as a couple of lines. Now of course we have to be accurate in this. You can't just abruptly start drawing some hidden detail lines. Alright, so if we take a look at sectioning is where I cut open a piece of material. Like I said to you, nuts and bolts, and then also washers you don't section. Other things that you don't section are keys. Right, this type of key that you can get there's a square key, you get a flat key, you get a dowel, you get a feather key if you see it that way. There's a Woodruff key, often been asked, and then this is a gib head key, which is this one over here, and then this is a taper key. Right, it tapers in other words it's smaller to the bottom than what it is at the back there. All right, so the purpose of the key is basically if you place it inside the shaft and place it inside the object that needs to be turned, if something happens with this object over here and it's abruptly stopped to work and the shaft is still turning at the speed of 3,000 revolutions per minute or per second or whatever the case might, depends on how fast it needs to go, then in that case the key will break off and it won't cause damage to either the more expensive parts of the shaft and also more expensive parts of the pulley or the wheel or whatever the case might be. Alright, so that's basically what you need to know. So here we go. With the key placed inside, you can see the key is now inside this object. It's a pulley, and it's been placed inside. Now there's a lot of detail inside there as well, because you will have the shaft reach or end, then you will have the bedding of the key on the bottom of the shaft, and you will also have the bedding of the key to the top of the pulley, and the key will be basically inside here. Right, and then also this goes deeper in towards that point where the shaft pulls in all the way up to that specific point over there. All right, so that is what you will get in this regard. Now if I go from there further onwards, you can see I can partly section an area. So in other words, I bit out of some sort of area out of the shaft to show the detail inside over here, showing the bedding of the key inside this area, whatever the case might be. There's also some hidden detail. Now again, like I said to you, the keys normally you don't hatch, so therefore that's clear. You've cut through the pulley to show the detail. You've bite off a piece of material out of this shaft to indicate what's the bedding and where does the bedding fit and where does a key fit, and that is all hatched in the process. We will get to the hatching and what is hatching all about. So off we go. There we go with the hatching of a detail inside a shaft. There's a hole being drilled in over here, and then also the hole is tapered, so therefore you want to show the machine maker what does it look like. So therefore there's a partly sectioned area that has been taken out, and from this area it shows the detail inside there. If it's not been taken out, of course that will be hidden detail lines of which you won't be able to see inside the shaft. But if it's been taken out, of course this will be solid lines in the process. Right, now this is also an important part that you have to take care of. This is a web or a RIP, reinforced web. Normally if you take a look at the three-dimensional view, if you put strain onto this part over here and it's fixed to the floor on this part, it will obviously break by the neck at that point over there. So to make this thing stronger, they normally put a piece of triangular like material inside there to make this, to support these two areas so it doesn't break off. And that's what happens over here, where you can see that is the rib itself. Now if I cut through this part, now there we go, cutting off the front part, the part in between me and the object will be taken away. It means that there's no definite line over there. You can see it's a casting, it's been casted out onto that part. Now if I do the hatching, of course that will take me a tremendous long time in doing the hatching all the way all over, because sometimes this can be significantly large in a drawing, for instance. So therefore we will fence off this part over here of which we have cut out, and we are allowed to cut through the middle of it. There we go, through the middle of that. But then we're not going to waste time on doing hatching in this part over here. Right, so in that case it tells you that you've got the reach part and the bottom part that has been sectioned, been cut off. In other words, this is the enforcement or the web, the enforced web that you see over there, and that you normally don't do the hatching on. All right, so that's what you see over here. Over here there's another example that you can see of webs. If you take a look at this part, it's been enforced. Normally if there's strain onto this part, let's say umbrella stands onto this part and it's been bolted to the ground, something like that, it means that it can easily break off by the neck of where this pipe is joining up with the base. So to make this stronger for all wind directions, it means that it has got 4 webs that has been placed over there. So now I can also cut through this part. So if I say, for instance, that's my section line, I cut through this area at that specific point, it means again that I will fence off that part. Although it's a casting, I will fence it off of what you see over here, and then from there on I don't waste time on doing hatching on webs, and of course the rest of the parts I need to do the hatching and show the hatching. Why is there no hatching inside there? Because it's a pipe, it's round, it's not, there's no material inside there, and that's the reason what you will get there. Now this part over here is a solid part. It's a cone like shape that you will get to a base plate or something like that. And then if you cut through this part over here on AA, for instance, it will be cut off. The part in between me and the object will be removed, and as I remove this part over here, you will see that there's no enforcement ribs placed predominantly at the ends or corners or whatever the case might be. It's a whole unit, and because of the fact that this is a whole unit, this whole area will be in that case hatched in the process. Right, so there's a big difference between webs and solid units, solid areas itself. Now many times it happens, this is now paper 1, I must just tell you, this is not quite applicable for paper 2, but the principle I want to explain to you, and I will explain it on the hand of paper 1 possible questions. This is a cone standing upside down on the sharp end of its head, in other words, if you see it that way. Now, of course, that cone is showing some detail to the bottom. Otherwise, this could have been a square if I just take a look at the top view. But now I can see it's going to a center point, which means this is basically the edge standing upside down on this specific point. All right. Now, if I do the hatching, if I cut off a piece of the material over here on AA, say for instance, I can determine those endpoints, do the hatching, but still you keep the hidden detail behind the hatching. So therefore, that's very important to see that the hidden detail is still visible in that case, in other words. All right. So make sure that you always show hidden detail behind hatching if the examiner is asking that. Now, for dimensions, of course, normally they don't ask you to do the dimensions, right? But now, if you don't understand the principles of dimensions, you're going to get quite confused, because there can be quite a significant lot of dimensions at this point itself. All right, so over here you can see that this portion over here is a dimension indicating to you an arrow, but now there's no dimension, there's nothing there. But in fact, this tells you from that point to that point, arrow towards arrow, that is the distance of 12 millimeters that you see over there. All right, so then also there's some rules according to, you can see that one extension line is extending much further than the gap between the object and the dimension. There you can see all the gaps over there, and over here the same. Then this is, of course, your extension on the extension line. All right, the extension line has been extended for about another 4 millimeters. And then, of course, your dimension line is where the dimension will stand on. These are all dimension lines over here, in other words, of what you can see, where the dimension will stand on. Then, if you take a look at that area, remember the arrows aren't fat arrows. It's thin, small arrows, the same size as what the size of the pencil lead is. The same size, you will go that way and this way in the attempt to draw the arrow. And then also the arrow will be more or less 3 millimeters long, so therefore it must be from there to there 3 millimeters in length. All right, then also for that portion, if it's too small to add a 12 inside there, you can add it like this part over here, saying from this point towards that point, the total is 12 millimeters. Right, then the place of the dimension will always be to the middle of it, so that's the middle of the line from there to there and from there to there. Also, the distance between one dimension to the other dimension, first of all, you start with about 12 millimeters, and then after that 10 millimeters, 10 millimeters, 10 millimeters for all the dimensions that you can get afterwards. All right. The dimension will always point to from the right to the left, and you will always draw from bottom to top. So that is indicating to you that's a number 12, in other words. All right, so there we go with that part, from left to right, from bottom to the top, in other words. And then if it's going over here, from left to right, and it's standing on the line, it's not hanging on the bottom of the line or hanging on the bottom of the line, it's on top of the line and seen from the right hand side. So for those right-handers, you can simply stretch over and write down 20. You can stretch over and write down 12 in that case. So you don't go from this side and try to squeeze in a 12 or a 20 or whatever the case might be. Okay, so these are different types of dimensions where you can place it on different areas. You will see normally the smaller ones inside, the bigger ones on the outside. Outside the view, you not draw dimensions inside the view, you all go outside the view and outside the view and on the outside over there. So that is what you need to know. You are allowed to use the extension of a center line in order to help you to draw the center point towards this bottom point of the dimension itself. Okay, then these are positional dimensions. It tells you the position of that center point is so far away, the position of that center point is so far from the bottom, it's so far from left to right of the center, and it's also so far, the position is so far from the bottom. This is size. In other words, it tells you from there to there, that's the size. From there to there, that's the size. From there to there, that's the size of that gap that you see over there. Right, then also radius dimensions. You will add it like this. You will add a line going through the center. So in other words, that arrow is touching the specific object, the circle or the radius, in other words, in this case. It's going through the center of that circle, downwards, and then from there outwards to build a platform in order to write radius 2, because there's not enough space inside here, so you can go outside there. And the same with this one, and the same with that one over there, always going through the center point, always going through the center point. Have a look over here. The center line only extends from left to right in a horizontal way. There's no vertical center line, because the more important line between the center line and the outside line will be the outside line, so therefore there's no center line shown over there. Okay, then of course, if you do the dimensions successive one after the other one, the smaller ones will be inside, then bigger, and the biggest one will be on the outside. Over here, you can also add a total dimension, an overall dimension, in other words. And then from here, diameters, if there's not enough space to do the diameter inside this area itself, then of course you're going to go outside and say this circle I'm talking about, touching it by the arrow, has got a diameter of 8. Or I can also go from this side to that side is diameter of 8, or still not enough space, from there to there, it is basically 8 of diameter. Right, so here we go. Also, it can be either stand inside if there's enough space, right? Keep away with the center lines in that case. It can stand inside, saying from there to there, has got a diameter of 31, and it can also be from top to bottom or left to right, it doesn't matter. That's the dimension over here, or in this case, that's the dimension from top to bottom over there. All right. Then if you go for a sphere, a circle, or a round circle, that can be same as SPH. The SPH tells you that is for a sphere, in other words, that is making a round thing, if you should not edge it off on the sides. And then over here, that is also the radius of what you see of there, and also the radius size of what you see in that case over there. Right, so that this area over here, it tells you it's not to scale. In other words, it's just been drawn freehand, and it's not perfectly. So it's either NTS behind it, or it can also be underlined, like in the case of here. It's underlined, and if it's underlined, it tells you it's not to scale. In other words, it's not to scale, what you see over there. All right, projection system symbols. First angle is graphic projection. I've explained to you, first angle, it goes through the target. So if this cone is smaller on this side, if I look at it from the left hand side, I will place it to the right hand side, and then of course I will see the smaller circle as well as the bigger circle. But the placement of this view as it goes through the target in first angle graphic projection tells you that this is, in other words, placed on the right hand side. All right, you don't need to show the top view. With third angle graphic projection, ladies and gentlemen, that is what you will see from this side inward. So therefore I will see this, but I will place it over here. So therefore the placement will be, in other words, on this side over here. So therefore there's the placement being placed. So this view is being placed to the left of the front view that you see over here. All right, in third angle graphic projection, third angle, that is normally your machine drawings and mechanical drawings that you will find in there. Right, now this is presentation of common features, ladies and gentlemen. Now common features will be nuts and bolts. Now this is grade 11 work, so I'm not going to go through the detail on how to construct the nuts and the bolt. Just know that this is what the nut and bolt looks like, and this is where you're heading to for grade 11 and 12. This is the bolt. This is what the bolt looks like. All right, you can see that the edges on this side and the edges on that side differ, because of the fact that this goes all the way to the top and it goes downwards again, and it's been edged off there and it's been edged off on that side. So that's what you will get over here and over there, and then that arc goes to the top, and that top will make a rectangular position on the top and also on the bottom, of course. All right, so then this is a shaft. This is an interrupted view. In this case, you can see that this shaft is actually much longer. It goes from there far to the left, but there's no space on the paper to doing so. It's 200 in length, so therefore this interrupts the shaft to a certain extent, telling that it's been broken off here for making it shorter. Still the dimension is the correct dimension, but there's nothing going on except for the same of what you've seen on this side and on that side over there. So that's an interrupted view. It's important to know that because the examiner asked this question during the exam of 2020 as well. All right, so it's possible in asking these things in questions. All right, this is a tapered shaft. You can see the shaft on this side much larger than what the shaft is on that side, so therefore it becomes smaller to the end, and this is what you see over here. It's tapered, in other words, a tapered shaft. Then there's a square on this shaft over here where you can see it's been made flat on the ends, and that is normally shown by a cross from corner to corner indicating the square on the shaft itself. All right, so this has also been asked in 2019 where there's a square part on the shaft, also in 2020 in a different question. Then knurling, this is what you will get with radio knobs, volume knobs and those type of things and so on. So that is the knurling, so that your hand doesn't slip. That's the purpose of that. It's also with your compass. You will see on your compass on the wheel you will also have these type of knurling that you see in that case. Now this is a diamond knurling. The previous one was parallel knurling. This is diamond knurling. You can see the previous one, it is parallel to each other, so therefore all those lines are parallel. So that's parallel knurling. And in this case, it's diamond knurling where it tells you it's going across. All right, so how do I draw these things? Of course, you don't have to draw the whole shaft from top to bottom, from left to right. It's just a portion of it, of what you're going to choose, and then you're going to show the parallel knurling. And also the same with diamond knurling. It's only a portion that you will find this knurling. It's not necessarily go all the way up to here. Now, most of you guys have been to a gym, have been to areas where you have to have good grip onto a rail or something like that, and that's what they normally do with this diamond knurling. It's a process that they can add towards this part to make diamond knurling itself. So there you go with the diamond knurling. You can see it's been asked in 2018, 2019 and several times or so. Alright, so this part over here, that's a circlip. Now for the circlip, you will see that if you cut through this part over here, if you cut through there, there's nothing going to be cut on the top, and on the bottom you will cut through this part over here. Alright, so in that case, over there's no hatching inside there. But on the bottom you will see that there will be hatching in that regard. So therefore there is some sort of hatching that you see. Then this is a spring. This is what the spring looks like, of course, you know. And then if I need to draw this, this is the way I'm going to have a flat end on the top, I'm going to have a flat end on the bottom, and it's going zigzag for predominantly the diameter of this spring from left to right. So in other words, that diameter will be on that side and that side the same from the center line towards either side. All right, so more or less 15 degrees on this point over here. This question, this specific principle was asked in 2020 exam paper. Then over here, you can have a look at the bearing itself. This is what the bearing profile look like. In other words, the bearing has been forced inside that area with, of course, a lot of grease and lubricant inside over here. And then we normally don't draw the detail of bearings like we have over here. We can just draw across through this part over here. So we will make use of the dimension of what it is from left to right. We will make use of the dimension from top to bottom, so therefore that dimension will be transferred to our drawing. And then once we're done with that, we're not going to draw the detail of this. We're simply just going to go straight for corner to corner, indicating that that is what you will get with a bearing itself. So we all know that that will be a bearing. All right, so then this is a bush. Now the purpose of the bush is to reduce the friction between the real machine part and the shaft that's been turning inside this area over here. All right, so this is what the bush will look like, more or less. They can see that it has got a shoulder on this side and a shoulder on that side. That's where the shoulder is, and where it's the shoulder. This hole goes right through in the middle, from there right through to that side, and then the shoulder brings you a smaller portion of material that will be placed over here. Now, if I have to cut through this part over here, and cut through AA in other words, then if I cut through this part, I will now see the profile of this part where it goes up and then down to that part going downwards up to this bottom part over here. So there's the profile of what you will see of that part. Now, because this is a solid unit, there's no seams over there, and it's not been added or welded onto that part as well. So therefore there's no solid lines in that case. All right, so this is often asked Last year, 2019, this question was asked in part of a question paper itself. All right, so then you will have things like spot phase, which is not applicable for grade 10 work. And the difference between a spot phase and a counter bore is the dimensions that you will get there. Now, if I go back to the spot phase, you will see if it's less than 4 millimeters, it's called a spot phase. All right, so that is 2.5, so this will be definitely a spot phase. The S phase is spot phase, in other words, it's a spot phase of what you see in that case. That's what the dimension will be indicating to. All right, and then it tells you it's 2.5 deep, so therefore it's only 2.5 deep. That's why it's called a spot phase. The spot phase can also rise for about 2.5 millimeters, so that can also be, then in other words, 2.5 millimeters, less than 4 millimeters. In other words, if I go to this part, or counter bore, right, or C bore, there you can see C bore or counter bore, C bore or counter bore. It's normally deeper than 4 millimeters. So therefore, in this case, this is 5 millimeters. So in that case, it is called a counter bore and not a spot phase. Right. Then this part over here, I think it's the last slide. No, there's about 2 slides left over. This is the indication of a gear itself. All right. So now if I take a look at this gear, you will see there's lots of detail, and the detail just continue, but it will take me a very long time, if it's not on a computer, to draw this all the gears itself. All right, so in that case, we're only going to draw a center line from there around, all the way around, indicating the center of this gear from top to bottom. That will be the center line that you will see in that case over there. All right, and then of course on the side view, this is what it will look like. That is the symbol for telling you that is a teeth. The teeth of the gear being cut in between those 2 lines. Or it can also be like that. If you section through that line over there, it will be hatched, in other words, all the way up there. So therefore it will be hatched all the way up there and all the way up there. If it's going in between the teeth, between that area, between the teeth itself, it's obviously going to be in that case. All right, so now it depends on the equal number of teeth, the top part and the bottom part. Or if it's unequal, we'll give you a clear area and an unclear area. And this is also been asked in 2018, 2019, as well as 2020. It's also been asked in 2020. Okay, ladies and gentlemen, this is now what I can offer you in terms of the PowerPoint slides. If I go to possible exam papers, question papers, this is what you will get within your exam. You will see that is the cover page, question 1, question 2, question 3. Now remember that this will be question 1. So if you take a look at that, that's question 1. It points out to you a drawing. It's giving you the 2 views of the drawing. Now we have to determine if it's the top view, the front view, front view and the top view. Now remember that this is third angle geographic projection. So if that is the front view, this could have been the bottom view, but it can't be, because a bottom view, if the front views look like that, it can't be showing the profile as what it is over here. So this is the front view instead. And look at it from in third angle geographic projection. It's been placed from above and then placed backwards towards that part, and that's the top view, in other words. All right, so that view is the front view, top view. It's giving you some information over here. If I can zoom in on this bottom part over here, you can see the information. It points out to you the title of the building, of the drawing is basically the cutting block, and then the owners is the H&M Steel Works. There's a date to that. The material, the description of the revision, it points out to you it's basically dimensions that needs to required for the description of the revision. So there was a revision on this part over here. Then of course it was drawn by Julius. The material was a soft steel. They need 100 of these ones, so therefore that's what they need. It's checked by David. It is the date was drawn on that. The date of checking this was on that part over there. The description of the revision was on that date over there. Yes, and then from there on, of course, this is the scale of the drawing approved by Tsiposiso, and then also the date approved when it was everything was done was on the 2nd of March in 2018. Okay, then the program, the CAD of AutoCAD, or the CAD program that was used is AutoCAD in this case. CAD, that's the file name, right? So the file number of it is basically then the CAD. The treatment will be paint, so afterwards we will paint this part over here. Changed by Dube, and then also drawn. This is the third drawing that you have seen on this part over here. The dimensions are all in millimeters, also important to understand. All right, so if we go to the question part of this question, you will see it's asking us here from the top the name of the manufacturing firm. All right, I think I will open up this slide now for you. The name of the manufacturing firm will be H&M Steelworks. All right, what is the scale of the drawing itself? Now we've seen the scale of the drawing, it's 1 to 2. What is the title of the drawing? Don't get confused, it's a manufacturing firm, and the title, that's a cutting block. How many units must be manufactured? 100 units. On what date was the drawing approved? Right, so when was it done? It was on the 2nd of March, we said. Right, and then what was the reason for the revision itself? The revision was, of course, there's no dimensions. They have to require dimensions, so therefore the dimensions was not placed inside over here. Which measurement unit is used? That is, of course, millimeters. Which material is used to manufacture the unit? That is soft steel, if you go that way. Who changed the drawing? That was Dube who changed it. And then the type of treatment afterwards, once you're done with it, it must be paint. Name view 2. All right, so if you go back towards, if you go back to this part over here, there's view 1, there is view 2. So view 2 will be this view over here, and that will be, of course, the front view. All right, name the line type at 1. All right, so there we go with 1. There's number 1 over there. That line type that you see over there is a dash line. In other words, it's a hidden detail or small dash line of what you will get there. All right, so there we go with the hidden detail line on that part over there. All right, name the quality of the line. The quality of the line numbered at 2. All right, so therefore if you go up here at 2, that will be a dark continuous line. So that will be a dark continuous line. The quality will be a quality, right, type A line that you will see there. Name the diameter of the hole at 4. So if you go to 4, there's no 4 on this view, the 4 is on that view over there. The quality that you see over there is basically that what you see, the diameter from left to right, which is that diameter over here, which is 22. All right, ladies and gentlemen, then over here the web, it's also been asked the web, so this is this portion over here, and then also the diameter at the hole at number 4. Yes, we have done that one. Other questions is determine the size of the angle at 3, so therefore you have to determine this angle, 27 degrees. Who checked the drawing? It's David's. Do the hatch lines, these are all the hatch lines over here. You can see there are still hidden detail in there. And then also the section line. Now, ladies and gentlemen, this question was asked in 2020 2 times in the same exam paper. All right, remember, if you cut through that part, it has got a dark end. I will show you with the next session, next question, I will show that to you. And then, of course, the arrow pointing this direction being placed backwards to see this view over here. All right, so the direction of the arrow, and you can name it A, and you name it A at that point. So those are all things 1, 2, 3, 1, 2, 3. So it's 6 half marks, it's 3 marks in total, just by paying attention in class. All right, thank you very much for this part. Then the last part I want to point out to you, what I want to explain to you. I'm going to close this current one. There's another example of a analytical question. Again, you've got a rip or a web over here. Again, you've got dimensions of what you have to read on these lines over here. Again, you've got an angle. Again, you have got the dimension at B. What is that dimension? Now, if you take a look at that dimension, if you scroll upwards, you will see that that is the dimension for this outer part over there, from there to there. It's also been asking you on the bottom the distance from there all the way up there. So therefore, dimensioning again from there up to there will give you a diameter of 100 millimeters. If it's diameter, then you write down diameter If it's radius, you write down radius. Depends on what the examiner is asking. There's a lot of detail over here. I'm not going to go through the detail now, but you can see there is the description of the revision that you will have over here. There's also the name, the shaft supporter. It's PC Stalwerke, or it's just PC Stalwerke Steelworks. This is in Boshoff Street. It's in Reddersburg that you will find. So where's the place where you can find it? Questions that can derive from this one is the material it's been made out of. It's cast iron, in other words. The number required is 50 of those one. The scale of it is 1 to 2. It's AutoCAD that has been used over here. Dimensions, all the dimensions are in millimeters. All right, the drawing file number, the file number is over here. It's approved, it's checked by, it's drawn by. Those are the dates for that, and those are the dates for this part over here, and that's with the dates for this part over here. All right, so that is what you can get. And of course, there might be some subject knowledge also. That's the last portion I want to point out to you. There you can see the hatching, but no hatching on the web part over there, and no hatching on that web part over there. And then also they ask you the symbol for third angle isographic projection. All right, so this is the front view, seen from the left-hand side, place on the left-hand side. That's what the symbol will look like. And this is also a question that was asked in 2020 National Senior Certificate Exam. So all of these things I've pointed out to you are actually important things that you have to know of, and that you need to know about what is going on. All right, so there again is the section line over here, and the direction of the arrow, it can't be pointed top to bottom, it must be from the bottom to top, with the darker ends on that side over there. I'll explain that to you tomorrow. All right, ladies and gentlemen, that is the end of the session. I thank you very much. I thank you for listening. I hope sincerely that this will help you. Like I say to you, that these questions are questions that will definitely be in your grade 12 year. So therefore, paying attention on this part over here will definitely roll out onto the next part. My next session will be then tomorrow. This next session will be on mechanical drawings, and the mechanical drawings will be then specifically for question 4. How to place the views, where to place the views, the bottom views, the left view, the right view, and how to understand the principle of third angle isographic projection. So from my side, thank you very much for listening, and I sincerely hope that this helped you a lot in understanding mechanical drawings. Thank you very much.